Hello, this is exercise 17A. It's a year 12 lesson, but it actually comes from the year 13 textbook because most schools and colleges will do this in year 13 instead of year 12. But we're doing it early just to make sure we get through all the work in plenty of time. So we're looking at the normal distribution, and we've got a couple of lessons on this. And today we're going to start off with looking and trying to find probabilities for this normal distribution using what we're going to call Z values. Now, first of all, we should point out that most things in real life are normally distributed. So if I look at, I don't know, say this is the weight or the mass of cats. So I look at a particular breed of cats, and I've made up cats as a completely random choice. And it might be I find out that on average they weigh, I don't know, 7 kilograms. I have no idea what a cat weighs, I'll be honest. But obviously, just because that's the average weight, and you could call it the mean, the median, or the mode in a normal distribution. Actually, if it's perfectly normal, all three of those things would be the same. But let's say we say the mean of the cats is 7 kilograms. The symbol for that would be mu equals 7. But what we're also interested in is how spread it out it is. And these notches here are meant to represent one standard deviation. So if I said the standard deviation was, I don't know, 1.2 kilograms, notice the symbols for standard deviation. So by the time we get to 8.2 kilograms, we're one standard deviation away. If I add on another one, 1.2, I get to 9.4. And by the time you get to 10.6, and each time, of course, I'm adding on an extra standard deviation. By the time I get to 10.6, I'm practically finished. There'll be very few of these cats which are heavier than 10.6. Almost none. Go the other way, take away 1.2, you obviously get 5.8. Hope we don't make any daft mistakes here. Take away another 1.2, I'd get 4.6. And by the time I'd get to 3.4, I'd practically have no more cats who are less heavy than 3.4 kilograms. And this is what a normal distribution does. It allows me to kind of gauge values between which I'd expect to find all the cats. Anyway, let's have a look at a few example questions. So this first one's about the normal distribution of John. He's apparently a very tall policeman, measures 192 centimetres, and his bosses ponder the question, is he the tallest policeman in the country? And I suppose the only way we know is if we know what on average most people are. And I can tell you that most people are 174 centimetres. This is average height, mean height for people. Now the symbol for this, again, is mu equals 174. We also would want to know the standard deviation. He certainly looks tall compared to this shorter female officer. And the standard deviation for men in Britain is 7 centimetres, give or take a bit. 7 centimetres is the standard deviation, so I write that as 7 like this. Notice I sometimes want the variance, which is sigma squared, and I could write 49, but in normal distribution it's very common just to write 7 squared. Is this significant? Well, let's first of all, on all these questions, we draw a normal distribution curve. That's our normal distribution curve. Notice I've put 174 in the middle, because that's what it told me it was. 7 centimetres is the standard deviation. Now we've got told he was 192, so I'm going to randomly pick a point over there, which is 192. And I suppose what I want to know is how many people are taller than him. What's the probability that someone is taller than him? And basically I colour in the section I want to find. I want to find this section. Now, I'm going to show you first of all what's called the Z method for doing this. So using Z values. And to find this, I have to work out how many standard deviations away from the mean 192 is. Remember, we got told the standard deviation was 7. So 174 plus 7, wherever that goes, that would be 181. Plus another 7 would be 188. So it's certainly more than 2 standard deviations. And there's a quick formula for doing this. The formula is x minus mu over sigma. So if I do it in this case, z equals, my x was the 192, the value of our policeman, minus mu, which was 174, divided by sigma, which was 7. And if I take that away at 18 divided by 7, and that's 2.57. Do on your calculator, check. So he's actually 2 and a bit standard deviations away. Now how big is this probability? This is the probability I want to find. So we now know that z equals 2.57 in our example. And I suppose the big question is, how do we use that to find the probability? Now, traditionally, what you had to do was look in a table. Now, here's an extract from an old-fashioned normal distribution table. Now, this, I've only, copied in some of it. It actually started at 0 and went down all the way down to, certainly down to 2.5. Ours was 2.57, so to use 2.57, you went down to the 2.5 row, you went across to the 7 row, and it told you the probability. In this case, it says 0.9949. So this is basically what you do. So you look at this, but the table only ever told you the less than, the probability that x is less than 192. Now, if you recall, we drew the normal distribution table. This was the 174 value. The 192, we wanted this probability, this tiny one, next to the 192. Actually, what it's told me is all the stuff I haven't coloured in. This is 0.9949. There's a very high chance, and there's a 99% chance that the average person will be under John's height. Or put another way then, because we want the probability of finding someone taller than him, it'd be 1 minus this figure in the table, and that's 0.0051, or roughly 0.5% is the chance of finding someone as tall as John, in fact taller than John. Now, is this a sign that this policeman is the tallest man in the country? It seems not. It seems there's lots of other people. So that sounds quite a low number until you realise there's, I don't know, say 70 million people in Britain, and probably quite a few people are taller than him. So the problem now is these tables aren't given to us now, and it's because there are such, they weren't the best and easiest things to use. So we now use our calculator. So let's see how to use our calculator. Using the class whiz then, we are going to do this question. It says if x is normal. Now the very first thing I would say to you is I like drawing these normal distribution curves. So immediately I'm drawing this normal distribution curve. It says x is normal. Mu is 55, so we write 55. Get used to this notation. And we always write the variance. We don't write sigma, so I'm going to write 4 squared. I know sigma squared is obviously 16, but I don't write 16, I write 4 squared. Down here, the mean is 55. What's the question asked? It says find the probability that the next value you get is less than 61. So 61 is over here. So let's just use the proper method now. It tells you what to do. It says menu, then 7, then 2. So everyone press menu, 7, 2. So menu, 7, 2. Right, done that. Now, a couple of things I need to highlight to you. Now, you have to, when you do this, it's going to ask you what your lower value is and what your upper value is. Well, I can tell you now, it basically refers to the area we've coloured in. So the upper one's easy. You can see it says there, it says 61. So the upper is 61. But the problem one is this lower one. And the trick is to realize that these are meant to go on forever and ever. And so all the way to the left, we can consider this to be minus infinity. And all the way to the right, we can consider this to be infinity. Now the problem is you can't type infinity or minus infinity into your calculator. And this time I only want the minus infinity, so I'm going to type this. Now look, I just put in a big negative number. I would personally always do minus 9999. So I have written that there, yes. Don't forget to enter your sigma. Notice it doesn't want sigma squared, it just wants the sigma, it wants 4. And your mu is 55. And when you've typed them in, press enter, and it comes up with the answer. So have I got mine in? 61 for 55, yeah, I've got mine in. I've got 0.933. Good, that's what it says, 0.933. And that's it, done. Here's another example. It says x is normal. So let's write this. X is normal. Notice n for normal. The mean is 81, and sigma is 3. So I'm going to write 3 squared. You always write the variance there, but on the calculator you put in just the 3. So again, if I draw this, it's worth seeing what this is all about. We're expecting to get 81. That's the mean, so we'll show that. Now it says find the probability that x is more than 79.2. 79.2 is smaller than it, so I'm going to draw it there. And it wants more, so actually, this time I'm colouring the right hand side. And that was 79.2. So what do? Well, I do lower equals 79.2. Remember, you do the area that you've coloured in. And this time we want all the way over here. This is positive infinity, so the upper is going to just be 9999. So I'm going to type this in, menu 7.2, lower, what was it, 79.2, the upper was 9999, sigma, it said, is 3, and my mean, my mu, is 81, so I type that in as well. Press enter, and I get my answer. And notice the great thing about this calculator is it just tells you the answer. The answer it reckons, according to me, I'll put it up here because I think my answer comes up otherwise in the same space. It says 0.7257. I'm going to call it 0.726. That's what I got when I did. Yeah, 0.726. So these are actually quite easy to do. Here's a little exercise for you to do, a couple. See if you can do them. I'm going to pause, or get you to pause the video, and then if you get them right, then we know we're on the right lines. Pause the video now. Look, I hope you've done that. Let's just run through them quickly. So this first one, draw the curve. So this is what I'd recommend you do. Show the middle of it. There's always this first number, 12. What's it want? Oh, by the way, notice this is sigma equals 5, not, I know it says 25, but that means sigma squared is 25. So sigma is 5, and it wants it between 15 and 16. Now 12's there, 15 must be there, and 16 must be there. I want that thin slither of a probability there. So these are actually easier, these in between 15 and 16 jobs. The lower is 15, the upper is 16. You don't have to put any infinities or minus infinities in, you just use the two numbers. My sigma is obviously 5, my mu is 12. So let's do that. Menu 7.2. What was it? It was 15, 16, 5, and 12. And I get 0.06. So I get 0.06. Now, three significant figures, 2, 4. And hopefully we will get the answer for that in a bit. Hopefully I've done that right. I'll soon check in a bit. This next one, what does it say? It says the middle is 205, so mark that on. I want the probability it's 230 or less. Now 230 is there. So this is no longer a thin slither, this is all of this. This is a big probability. So what do? Well, lower is equal to, well, notice it's over here, so that's the minus 9999. My upper is the 230. And obviously my sigma is, now again, be careful, 400, they're trying to trick you. Sigma squared is 400, so therefore sigma is 20. And that's probably where people go wrong, things like that. And 205 for the mean. So that's what I've done when I typed it in last time. Yeah, it looked all right. So negative 9999, 230 for the upper, 20 for the sigma, and 205. And I get 0.89. So the great thing about this is it just, you don't have to do any work to it. Once you type it in properly, that is it. It's almost like, is that it? Is that it? All you have to do? And the answer is yes, that is all you have to do, because both of those were right. Look, a few facts about the normal distribution we meant to know. Approximately 2/3 of the data lies within one standard deviation of the mean. Now, what does that mean? In terms of the picture, I suppose, you'll notice this. In fact, it's one standard deviation either side. It's actually 68.2% according to this diagram. But roughly 2/3, this is actually the fact that you're meant to know. Roughly all the values that are possible, 2/3 will lie within one standard deviation. Roughly 95% will lie within two standard deviations. You can see that here. If you add those together and those together, within two standard deviations, it's roughly 95%. And if you go to 3 standard deviations, that should say 3, I've just realized it's a mistake. If you go within 3 standard deviations of the mean, it's almost all the values. Look at that, 99.7%. Now, we haven't got time to practice this now. We'll do that at the start of the next lesson. It'll give me a chance to reiterate what I've taught you. But we're then ready, effectively, to do, once we've done a couple of questions, exercise 17A. So, okay, I'll Hopefully that makes sense, and I'll see you in class.